Welcome to Part 3 of the Particle Size and Shape Characterization video course. We will continue with particle size. Let's jump right in. During this class, we will discuss the measuring of particle size. A spherical particle can be defined using the diameter. This, of course, is the simplest approach. All aspect ratios are equal to each other. Non-spherical particles can be defined through multiple length and width measurements. This approach provides greater accuracy, but also adds to the complexity. Thus, most measuring techniques assume that every particle is a sphere, creating a comparable spherical diameter. This is fundamentally the physical measured value and defining the size of the sphere that possibly produces the approximate data. Even though this method is crude and not exact, the shape of particles produced in the bulk of industrial processes are such that the spherical supposition doesn't cause serious difficulties. Problems can nevertheless arise when the individual particles have a large aspect ratio, such as fibers and needles. Each measurement technique detects size through the use of its own physical principle, creating variations in shape factor results.
For example, a sediment meter measures the rate of fall of a solid through a viscous medium. Other particles in the container walls tend to slow the rate of fall. Flaky or plate-like particles will maximize drag while settling, shifting the measured particle size into a smaller range. Sieves tend to accentuate the second smallest measurement particle range because of the way particles must position in order to pass through the mesh. A light scattering device such as dynamic light scattering technology, sometimes referred to as photon correlation spectroscopy or quasi-elastic light scattering, as well as laser diffraction, usually used in the submicron range, will average out the various dimensions as the particles flow randomly through the light beam, producing a distribution of sizes from the smallest to the largest dimensions. Microscopy analyzers can measure multiple particle size values. An image analysis defines the non-spherical particle characteristics by measuring the longest and shortest diameters, perimeter and projected area. Of course, it is also possible to use the microscopy analyzer to determine the spherical diameter equivalent.
All particle size analysis instruments are capable of measuring and reporting the particle size distribution. Only in rare situations does it suffice to measure only a single value. This result is hardly representative. It is common practice to analyze the entire particle size distribution as opposed to just a single point on it. It is important to adhere to the established industry accepted standards such as ASTM and ISO. In our next video, we will go deeper into particle size distribution. Thank you for watching.